everyone, this is Mrs. Hanson, and this is lesson 2-5, Rational Functions, video 2.56.57 and .58. Our learning target for this video will be for students to be able to solve rational equations. Alright, so looking at rational functions, we're asked to solve this rational equation, and we have x minus 4 over x minus 6 equals 0. Now, one thing we can look at, there's a couple different ways to do this. One way being that if I have x over 1, because if we don't have a denominator here underneath the x, we can put a 1 underneath it. So we have x divided by 1 is the same thing as x. And if we have 4 over x minus 6 equals 0, looking at this, we are subtracting two fractions, right? We have a fraction right here and a fraction right here. And in order to subtract fractions, we have to have a common denominator. So to solve this, I'm going to go ahead and get a common denominator. And I have x over 1 times, I'm going to multiply this fraction by x minus 6 on top and x minus 6 on bottom, because this fraction here, right here, has a denominator of x minus 6. So if I multiply the first fraction by x minus 6 on top and on bottom, then I will have a common denominator. So over here I'm going to do nothing to the second fraction because it already has a denominator of x minus 6. And when I multiply the first fraction by x minus 6 on top and bottom, on top I'm going to multiply x by x minus 6, which means I need to use the distributive property. So I get x squared minus 6x all over x minus 6 minus 4 over x minus 6 equals 0. Now, because I have a common denominator now of x minus 6 for both fractions, I can go ahead and subtract the numerator. So I have x squared minus 6x and then minus 4, which gives me x squared minus 6x minus 4 all over x minus 6, which is equal to 0. So we have this fraction here that we need to solve, and to undo dividing by x minus 6, to undo this dividing, because we have x squared minus 6x minus 4 divided by x minus 6, to undo dividing, we would go ahead and multiply both sides by x minus 6. So if I multiply by x minus 6 on both sides, okay, I get 0 times x minus 6. The x minus 6's on the left side cancel out, and we are left with x squared minus 6x minus 4 equals 0 times x minus 6 is just going to give me a big fat 0. So I want to know where x squared minus 6x minus 4 is equal to 0. I can look at this and try and factor. I don't see an option where there's two values right here that multiply to be negative 4 that also add to be negative 6. So looking at this quadratic, I know that it's not going to be factorable. So then I'm going to have to use a quadratic formula. So using quadratic formula to find my solutions. A reminder that x equals negative b plus or minus square root b squared minus 4ac all over 2a is the quadratic formula. In this example, we have a is 1, b is negative 6, and c is negative 4. So if I take the opposite of b, that gives me 6 plus or minus square root of 36 minus 4 times 1 times negative 4 all over 2. And I get 6 plus or minus square root of 36 minus, if I multiply these three terms together, these three numbers together, negative 4 times 1 times negative 4 is going to give me a positive 16. So I end up with 36 plus 16 there, all divided by 2, which then gives me 6 plus or minus square root of 52 divided by 2. So my solutions here, if I have 6 plus or minus square root of 52 over 2, I'm going to go up here and I have 6 plus or minus square root of 52 can be broken up into the square root of 4 times 13, which is square root of 4 times square root of 13, or 2 square roots of 13. Square root of 4 is equal to 2. So we have up here 6 plus or minus 2 square roots of 13, because square root of 52 is the same as 2 square roots of 13, all divided by 2. And since 6 and 2 are both divisible by 2, I can simplify this as 3 plus or minus square root of 13. So my solutions to this rational equation are x equals 3 plus square root of 13 and 3 minus the square root of 13. So I'm going to write out my answers as 3 plus square root of 13 and 3 minus the square root of 13. Okay, it's time for you to check your understanding. I want you to solve 9 over x minus 5 plus 3 equals 0. Your goal is to solve for x in this problem and find the solution, either A, B, C, or D, and go ahead and submit your answer when you're complete. Okay, looking at this question here, we have 9 over x minus 5 plus 3 equals 0. So if I'm going to get a common denominator here, because the 3 has a 1 underneath it, I'm going to multiply the second fraction by x minus 5 on top and by x minus 5 on bottom. If I get a common denominator, then I have 9 over x minus 5 plus, I'm going to distribute the 3 here to get 3x minus 15. All over 1 times x minus 5 is just x minus 5. Still equal to 0 on the right side. And because I have a common denominator of x minus 5, I can now add my numerators. So I'm going to get 9 plus 3x minus 15 on top. All over x minus 5 equals 0. And if I simplify this, I can combine like terms. The 9 and the negative 15 can be combined for a negative 6 all over x minus 5, which is still equal to 0. Now, since I have 3x minus 6 over x minus 5 equal to 0, I can multiply both sides by x minus 5 to undo dividing by x minus 5. So I'm going to multiply by x minus 5 on the left side and on the right side, which is going to cancel out with the denominator. So I get 0 equals 3x minus 6. And if I solve this equation, 3x minus 6 equals 0, 3x minus 6 equals 0 implies that 3x equals 6 when I add 6 to both sides. So if I add 6 here and 6 here, and divide by 3, I get x equals 2. So our solution to this problem is x equals 2, which is answer C. And obviously you could check your solution by going in here and substituting 2 for x. So if I take 9 over 2 minus 5 plus 3 should give me 0. So 9 over 2 minus 5 is negative 3. 9 divided by negative 3 plus 3 should equal 0. 9 divided by negative 3 is negative 3. And negative 3 plus 3 gives me 0. So my solution checks out. All right, so next example is going to take a look at solving rational equations with extraneous solutions. So remember we talked about in a previous lesson what an extraneous solution is. It means that it is a solution that is not valid when you check it. I like to call them a fake solution. And if you go back and check your solutions at the end and it doesn't satisfy the original equation, then we know that that solution is not valid and it is indeed extraneous. So what we're going to do here is we are going to solve this rational equation. Right here, this x has a 1 underneath it. And in order to add these two fractions on the left side, I'm going to go ahead and get a common denominator. In order to get a common denominator between these two fractions, I need to multiply the first fraction by x minus 1 so that this fraction ends up with a denominator of x minus 1 on bottom. So I'm going to multiply x minus 1 over x minus 1 times x over 1 plus x over x minus 1 equals 3x minus 2 over x minus 1. Now, if I multiply these two fractions together, remember multiplying fractions, we multiply the numerators together, which is going to give us x squared minus x. And if I multiply the denominators together, I just get 1 times x minus 1, which is x minus 1. And I have to add to that x over x minus 1, which is equal to 3x minus 2 over x minus 1. So this whole first part here, the work that I did in the first step, is just to get a common denominator between the two fractions on the left side of the equation. Now that I have the same denominator here and here, I can combine these two fractions into one. So what it's going to look like is x squared minus x plus x, because I can combine my numerators, all over x minus 1 is equal to the fraction 3x minus 2 over x minus 1. So what I've done is I've just combined these two fractions into one fraction here. In this fraction, we have not done anything with the right side of the equation yet. Okay, so looking at the equation that we're left with, we have two fractions equal to each other, and this fraction on the left side, the negative x and positive x can be combined. They cancel each other out. And I'm really left with x squared over x minus 1 equals 3x minus 2 over x minus 1. Now, this is kind of a really nice problem here because we have a proportion, which means a fraction is equal to another fraction. And in this fraction right here, we can see that this denominator on the left side is equal to the denominator on the right side. If you get a proportion where two fractions are equal to each other and the denominators are the same, what that implies then is that the numerators here and here have to be equal. So only when my denominators are the same in my proportion, when the denominators are the same, when two fractions are equal to each other, then my numerators are equal to each other. So I can state that x squared equals 3x minus 2. The only time I can set these numerators equal to each other, again, is when my denominators are equal. So I'm going to solve this resulting equation. I'm going to get all these terms on the same side. So I'm going to say x squared. I'm going to subtract 3x and add 2 to both sides, which means that we have x squared minus 3x plus 2 is equal to 0. Now looking at this quadratic trinomial here, I need to multiply, if I'm going to factor, the two numbers have to multiply to be positive 2, but also add to be negative 3. The two numbers that do that are negative 2 and negative 1, right? So x minus 2 times x minus 1, if you have a negative 2 and a negative 1 multiplied together, that gives me positive 2. And when I multiply the outer term and the inner terms, negative 1x and negative 2x give me a total of negative 3x as my middle term. So when I set these factors equal to 0, x minus 2 equals 0, and x minus 1 equals 0, that implies that x equals 2 and x equals 1. Now, in the instructions here, it indicates that we might have extraneous solutions. So what we need to do is we need to take these two solutions, x equals 2 and x equals 1, and plug them back into the original equation to see if one or both of them are extraneous. Okay, so what we're looking at here is the original equation of x plus x over x minus 1 equal to 3x minus 2 over x minus 1. The solutions we got were x equals 2 and x equals 1, and I need to check both of them. So I'm going to plug 2 in first. I get 2 plus 2 over 2 minus 1 needs to equal 3 times 2 minus 2 over 2 minus 1. So if I simplify here, I get 2 plus 2 over 1 equals 6 minus 2 over 1. And 2 divided by 1 here is 2. So when I combine that with a positive 2 here, I get 4 equals, and on top here I get 6 minus 2, which is 4 divided by 1. So 4 divided by 1 is indeed equal to 4, so that solution checks out. So x equals 2 is a valid solution. Now what I'm going to do here is I'm going to check x equals negative 1. I get 1 plus 1 over 1 minus 1. And I can already see that this is not a valid solution because 1 minus 1 right here in the denominator of the original equation has me dividing by 0. And we would know by just looking at this equation that 1 would be restricted from the domain. We would not be able to use 1 for x because when we substitute 1 for x, we end up dividing by 0. So x equals 1 is an extraneous solution because when I substitute it back into the original equation, I end up dividing by 0, which is a big no-no. So our only solution to this problem is then x equals positive 2 rather. So we have a single solution at x equals 2. All right, it's time to check for your understanding. I want you to solve the rational equation x over x plus 2 plus 6 over x minus 5 is equal to 14 over x squared minus 3x minus 10. And we have 4 choices, A, B, C, or D. Make sure you check your answer for any extraneous solutions before responding. Okay, so what we're going to do on the left side of the equation here is we're going to get a common denominator. That means that I'm going to divide this first fraction here by an x minus 5 on top and bottom. And I'm going to multiply this second equation here by an x plus 2 on top and bottom. So I'm going to get x times x minus 5 all over x plus 2 times x minus 5 plus 6 over x minus 5 times x plus 2 on top and bottom. Put parentheses here. And that is all equal to 14 over x squared minus 3x minus 10. And if I'm looking at this problem, I'm going to start by multiplying the numerator. So I'm going to distribute that x to get x squared minus 5x plus, I'm going to distribute the 6 here. I'm going to get 6x plus 12 all over a denominator. If I FOIL this and FOIL this, they're going to be the same. I just switched around the factors, and multiplication is commutative. So if we multiply x plus 2 times x minus 5, it is the same as x minus 5 times x plus 2. So if I FOIL out this binomial, I'm going to say x squared minus 5x plus 2x minus 10 equals 14 over x squared minus 3x minus 10. Now, if I combine like terms here, I get x squared. I'm going to combine these like terms on top as well. I get 1x plus 12 all over x squared minus 3x minus 10 is equal to 14 over x squared minus 3x minus 10. Now, like we said in the previous example, when you have a proportion, when you have a fraction equal to another fraction, and your denominators are the exact same, basically you can just ignore the denominators and state that the numerators are equal to each other. So if we get x squared plus x plus 12 equal to 14, what I'm going to do is I'm going to move the 14 over to this side and get x squared plus x minus 2 equals 0. Now, looking at this quadratic here, I want two numbers that multiply to be negative 2, right here. Two numbers that multiply to be negative 2 that add to be positive 1. That means that this factors into x plus 2 and x minus 1, because 2 times negative 1 is negative 2, and when I add 2 and negative 1, I get a positive 1. So my solutions here are negative 2, right? If I go up here, if I set x plus 2 equal to 0, I get x equals negative 2. And if you have x minus 1 equals 0, x equals 1. So I have two solutions here. I'm not ready to choose A quite yet, because I want to make sure that one of these two solutions is not extraneous, and in order to do that, I need to plug these answers back into the original equation and make sure that the two sides are equal. Alright, so the first solution I'm going to check is negative 2, and I can already see that this solution is extraneous because when I plug negative 2 in for the first fraction, I get negative 2 over negative 2 plus 2, which then gives me a 0 in the denominator. So I already know that negative 2 is an extraneous solution, and I can move on to checking positive 1. So if I check positive 1, I get 1 over 1 plus 2 plus 6 over 1 minus 5 equals 14 over 1 squared minus 3 times 1 minus 10. This gives me 1/3 plus 6 over negative 4 equals 14 over 1 minus 3 minus 10. I get 1/3 plus 6/4 is the same as 3/2, and it's negative because the 4 on bottom is negative. And that gives me 14 over 1 minus 3 is negative 2. Negative 2 minus 10 is negative 12. So I get 1/3 plus negative 3/2 is equal to negative, if I simplify 14/12, that's going to give me negative 7/6. So in order to add these two fractions together, I need a common denominator. So I'm going to multiply the first fraction by 2 on top and bottom, which gives me 2/6. If I multiply the second fraction by 3 on top and bottom, I get negative 9/6 is equal to negative 7/6. If I combine these two fractions, because I have a common denominator, I can subtract the numerators. 2 minus 9 is negative 7 over 6 equals negative 7/6. And since the two sides are equal, we know that x equals 1 is a valid solution. So therefore, our response should have been B. Alright, it's time to look at a real-world application problem here. In this example, we're going to discuss water current, and the rate of the water current in a river is 4 miles per hour. And in 2 hours, a boat travels 6 miles with the current to one end of the river and 6 miles back. If r is the rate of the boat in still water, r plus 4 is its rate with the current, and r minus 4 is the rate against the current. And thus 6 over r minus 4 plus 6 over r plus 4 equals 2. Find r. Now I want to do a little bit of explanation how they came up with this equation here. the 6 over r minus 4 plus 6 over r plus 4 equals 2. Well, if you remember, distance is equal to rate times time. And if I solve this equation for time, I can divide both sides by the rate, so distance divided by rate equals time. Now, each of these equations then, what we can say is our time downriver plus our time upriver, or back, is equal to 2 hours. It says in 2 hours a boat travels 6 miles with the current to one end of the river and 6 miles back. Now, I can substitute here in this equation, time downstream plus time upstream is equal to 2 hours. Well, time downstream is distance downstream divided by rate downstream, and plus the trip back up the river is distance upstream divided by the rate upstream, which is equal to 2. Now, the distance traveled downstream or with the current is 6 miles, and obviously it also takes 6 miles to get back to where you started from. So both of these distances here, distance downstream is 6 and the distance upstream is 6, but the rates are different. The speed at which you can go downstream or travel with the current is different than when you're fighting the current going back. So when you're with the current, your rate, if R is your rate in still water, right here, then you're actually going to speed up because you have the current at your back pushing you downstream. So your rate is R plus 4. And on the way back, when the current is working at you or working towards you, so here's you going upstream, but the current is pushing you back a little bit, it actually slows you down, so your rate is R minus 4. And the total distance traveled then was 2, or the total time traveled was 2 hours, which is how we got this 2 here. So this is how they came up with the equation. I wanted to kind of discuss how they came up with this equation. It's not just arbitrary. They didn't just pull it out of thin air. So I wanted to do some discussion about how distance, rate, and time are related, and how those two fractions added together end up equaling 2. So anyhow, we're not done with the question here. Our goal is to find R, and on the next slide we're going to go ahead and solve this equation here for R. Alright, so we have our equation, 6 over r minus 4 plus 6 over r plus 4, and if I'm going to add these two fractions together on the left side of the equation, I need a common denominator. So what I'm going to do is I'm going to multiply both top and bottom by r plus 4. So we get 6 times r plus 4 on top, and r minus 4 and r plus 4 on bottom. And then the second fraction right here, I'm going to multiply both the numerator and the denominator by r minus 4. And I still have 2 on the other side of the equation. So what I have now is I can combine these two fractions together because I have the same denominator, which is going to be, if I multiply or FOIL this out, I get r squared minus 16. And on top, if I distribute the 6 here, I get 6r plus 24. And if I distribute the 6 here, I get 6r minus 24 equal to 2. And on the numerator, the positive 24 and the negative 24 cancel each other out. And you're left with, if I move up here, I get 12r over r squared minus 16 equals 2. Or since I'm dividing by r squared minus 16 here, I could multiply both sides by r squared minus 16. And on the right side then, I would end up with 2 times r squared minus 16. Now if I distribute the 2, I get 12r equals 2r squared minus 32. And if I collect all the terms on the same side by subtracting 12r on both sides, I get 0 equals 2r squared minus 12r minus 32. Now I have a quadratic here, and always what the first thing you want to do is try to factor it if at all possible. And I can see that all three terms here, 2r squared, negative 12r, negative 32, are divisible by 2. So I'm going to factor out a 2, and I'm left with r squared minus 6r minus 16, which is equal to 0. And this quadratic, I'm looking for two numbers that multiply to be negative 16 that add to be negative 6, which give me r, let's see, negative 8 and positive 2. Negative 8 times positive 2 is negative 16, but when I add negative 8 and positive 2, I get negative 6. So if I set both of those factors equal to 0, I get r equals 8 and r equals negative 2. Now, one thing I can see here, I have to check for extraneous solutions. Since we're solving for a rate, we have r equals 8 and r equals negative 2. I'm kind of skeptical that our rate can equal a negative quantity. Rate is probably going to be positive because it also kind of discusses well, your distance divided by time, and you can't really have a negative distance, and you can't have a negative quantity of time. So your rate is unlikely to be negative. So I'm going to just say that rate equals negative 2 is an extraneous solution, which gives me a chance to check that r is equal to 8. So what I'm going to do on the next screen is just check to see that r equals 8 checks out, and we will have our solution. Alright, so checking our solution of 8, r equaling 8, I get 6 over 8 minus 4 plus 6 over 8 plus 4 equals 2, and I get 6 over 4 plus 6 over 12 equals 2. And if I multiply top and bottom here by a positive 3, you get 18 over 12 plus 6 over 12 is equal to 2. And the reason why I multiplied by 3 here is so that I can get a common denominator of 12 and combine my two fractions, which gives me 24 on top. 18 plus 6 is 24. 24 divided by 12 is equal to 2, which is a true statement. 24 divided by 12 is equal to 2. Therefore, r equals 8 is a valid solution. And one thing I should note is that our unit of measurement is miles per hour, because remember, rate is a distance divided by time. Since our distance was measured in miles and our time is measured in hours, then our unit of measurement is miles per hour. Alright, it's time for you to check your understanding. This example has to do with electronics. Suppose the current I in amps in an electric circuit is given by the formula I equals T plus I divided by 8 minus T, where T is time in seconds. At what time is the current 2 amps? So remember, the current is I, so it's telling you that I equals 2, and you are trying to figure out then what the time is where the current is 2 amps. So your goal is to take this equation, substitute 2 for I, and then solve the equation for T. Select your response, A, B, C, or D, and press submit. Okay, so selecting or replacing I with 2 amps, I get 2 equals T plus 2 over 8 minus T. What I'm going to do is I'm going to go ahead and get a common denominator here. So I have a 1 underneath the T. I can multiply this first fraction by 8 minus T. So I get 2 equals T times 8 minus T all over 8 minus T plus 2 over 8 minus T. And now that I have a common denominator, I have 2 equals 8t minus t squared plus 2 all over 8 minus t. And to undo dividing by 8 minus t here, I'm going to multiply both sides by 8 minus t. So I get 16 minus 2t equals t squared, let's say negative t squared, plus 8t plus 2. Now, I need to get all these terms on the same side. This is a plus here, by the way. It looks like a 1, but it's actually a plus. I need to get all the terms on the same side of the equation, so I'm going to do that on the next slide and go ahead and solve the quadratic. Alright, so we have 16 minus 2t equals negative t squared plus 8t plus 2. I'm going to collect all the terms on the same side, so I'm actually going to move these 3 terms on the right side of the equation over to the other side. So I'm going to add t squared, so the t squared will be positive. I'm going to subtract 8t here from both sides. If I add t squared here, that makes positive t squared over here. And so these would cancel. Negative 18, negative 2t is negative 10t. And if I subtract 2 on this side as well, 16 minus 2 is positive 14. And then we are left with 0 on the right side of the equation. Now what I'm looking for is 2 numbers that multiply to be 14 that add to be negative 10. The only thing I can think of that multiplies to be 14 is 7 and 2 and 14 and 1. Neither of which multiply or add actually to be negative 10. So it looks like this is not factorable because I cannot find 2 numbers that multiply to be 14 but also add to be negative 10. So 1 and 14, negative 1 and negative 14, negative 2 and negative 7, and positive 2 and positive 7. None of these add up to be negative 10. So I'm going to go ahead and use quadratic formula. X equals the opposite of b plus or minus square root b squared minus 4ac all over 2a, which then leaves us with the opposite of b being, erase this real quick, opposite of b is opposite of negative 10, so that's positive 10, plus or minus negative 10 squared here is going to be 100, minus 4 times 1 times 14, all over 2 times the a value. The a value, or the lead coefficient, is 1. So I get 10 plus or minus square root 14 times 4 is 56, so 100 minus 56, and divided by 2, I get 10 plus or minus square root of 44 all divided by 2. Now, 44 is not a perfect square, so I'm going to have to go ahead and use my calculator to help me out on this. I know roughly that square root of 44 is a little bit less than 7, just because square root of 49 is 7. So when I square root 44, we should get something a little less than 7. So when I plug in 10 plus the square root of 44 divided by 2, I get 8.31. And when I take 10 minus the square root of 44 divided by 2, I get 1.68 seconds. So looking at our multiple choice responses, the appropriate response is A. As A said, 1.7 and 8.3, which are the closest responses to the responses that we got.